You get 2 rewrites per semester. If you just got one question wrong, like everything else, if it's the word problem that threw you, you should be able to get everything else, right? But we're not going to waste time and just sit there staring at a word problem. If you didn't know what you were doing, you weren't going to probably pick it up. Is anyone still writing? Hopefully now you know what you need to do, or you'll remember what you need to do when you see a percentage and where that can take you, what path that can take you down. And we did talk about it in the lesson. There was similar questions on manipulating on the handout, so you should be able to manipulate. But anyways, 5.6, confident intervals. We often hear statements such as 80% of dentists recommend this toothpaste with results accurate within 2 percentage points, 19 times out of 20, or something along those lines. We can interpret this result. We need to consider the confidence interval, the margin of error, and the confidence level. So those are the 3 things we're going to learn how to do, and they're fairly easy, okay? A confidence interval is a range in which a polled or surveyed value X is predicted to lie. The confidence interval may be expressed using a plus or minus notation, such as 54% plus or minus 3.5%, or a range from 50.5% to 57.5%. Either way is acceptable. The confidence interval has the form X, which would just be our percent, plus or minus the margin of error, where the margin of error is expressed as a percent. So in the example above, because I think you got a little bit of room to write there, our confidence interval is going to be 80% plus or minus the margin of error, so how accurate it is, which is 2%. Okay, so that is our confidence interval. I can write it like that, or I could actually do the math part. So I could subtract 2 from 80, which would be 78%, and then I add 2% to 80. Okay, and that's the interval. So from 78% to 82%. Either way you want to write it is fine. Okay, we use this when we have to calculate actual numbers, okay? But so we need to know how to write both. Margin of error is the possible difference between the estimate of a value you are trying to determine, as determined from a random sample, and the true value for the population, usually represented as plus or minus. So from our example above, it would be plus or minus 2%. Okay, that's our margin of error. So our margin of error goes into our confidence interval. A confidence interval is used to make predictions about a population based on samples from the population. A confidence interval is affected by the margin of error or sample size. So if the sample size stays the same, the margin of error increases as the confidence level increases. And then if the confidence level stays the same, the margin of error decreases as the sample size increases. And I don't know if we have, do you have that definition on there? Okay, maybe let's write that just so you have what confidence level is. And it's the likelihood that the result for the true population lies within the range of the confidence interval. So like how accurate are they? And I'll give you a second to write that. Okay, so from the example above, our confidence level, so the likelihood that it holds true, is 19 times out of 20. Okay, so 19 out of 20 is our confidence level. And then we can usually write that as a percent. So we take those two numbers, we divide it, times it by 100. I don't know what that is as a percent. 90, 45, and 50, 95%. I think. Yeah, thank you. Yeah, so those are the three things we have to remember, and now we're just going to look and answer questions based off those three. Okay, so again, a nice little brain break from chapter 5.5. But that seems like what we're going to need to focus some of our attention on the next, or tomorrow, I guess. The telephone surveyed. A survey of 500 randomly selected people was conducted in an urban area. The survey determined that 35% of Canadians from 24 to 45 years of age have an electronic book reader. The results are accurate within plus or minus 5% points, 19 times out of 20. The number of people in this age range in Canada in 2011 was approximately 8.7 million. It is assumed that the ages are normally distributed. So question A says, what range of people owned an electronic book reader? So what was the percentage of book readers? Let me read that question over again. Okay, 35%, so that's our starting point. Okay, and how accurate were the results? Within how many percentage points? 5. And it says it wants the range of people, so it doesn't want the percent. It wants actually how many people there were. But we're going to change our range to be, we're going to get rid of the plus and the minus. We're going to do the math. So 35 minus 5, 30% to 40%. So that's the range of percent, okay? They want to know how many people, so how many people were surveyed. 500, okay, so 500 people were surveyed. We want to know of the 500 what 30% would be. So what am I going to do with 500 and 30%? Multiply. And I'm going to change this to be a decimal. I'm going to do the same with the 40. And this is going to give me the range of people now. So I had the range of percent, now I want the range of people. Percent, 50% of 300 would be 150. Is it 150? 50% of 400 would be 200. Okay, so our range of people is 150 to 200 people. Okay, so we have to pay attention. Are they wanting just the interval itself, or do they want it in people or cars or whatever they're talking about in that example? B says determine the certainty of the results. So basically how accurate or the likelihood that that would happen, which means this is the confidence interval. How confident were they about the results? Say that louder. 19 times out of 20, yep. Which we already know is 95%. see how many people in Canada between the ages of 24 and 45 years would you expect to own an electronic book reader based on this result. So our answer, our certainty is 95%. So we are just going to take the population in 2011 and times it by the 95% because that's the certainty. We're saying 19 out of 20 times it will happen. So that 8.7 million times 0.95, because that's how accurate it is. So 8.7 million would be like 8,700,000 times. Okay, but if you just do 8.7 times it, then you're just gonna have a decimal and you add the word million after. And I will not know this answer. No quick little trick for that one. So you can either write it in as 8,700,000 or you can just go 8.7 times 0.95. Choice is yours. How many you got on your calculator? 3? I'll take all 3. Okay, and then we would just write the word million after. If you typed out all your zeros, you would just have the whole number. We got one more question. Not this one, I don't think. Something about baseballs, I think. To meet regulation standards, baseballs must have a mass from 142 grams to 149 grams. A manufacturing company has set its production equipment to create baseballs that have a mean mass of 145. To ensure that the production equipment continues to operate as expected, the quality control engineer takes a random sample of baseballs each day and measures their mass to determine the mean mass. If the mean mass of a random sample is 144.7 to 145.3 grams, then the production equipment is running correctly. If the mean mass of the sample...
BBL, March 5th day, come down to the canteen within like 20 minutes, right when lunch is starting, get yourself a BBL. We know you want it.
This is the last time, you guys. This is the last time we're going to hear it. Riel, you want to sing? If the mean mass of the sample is outside the acceptable level, the production equipment is shut down and adjusted. The quality control engineer refers to the chart below when conducting random sampling. So we have a 99% confidence level. We need to sample 110. For 95, we need to sample 65, and then for 90, sample 45. What is the confidence interval and the margin of error the engineer is using for the quality control tests? Any guesses? There's a lot of information in that sentence. And it says the engineer, so the second half is the engineer part. What was the range for the mass for the engineer? What? I wouldn't be looking at me, I'd be looking at the paper and trying to read. And someone answer the question, what is the range for the mean mass for the engineer? It narrows down a lot of the numbers if I'm asking for a range. Yes, thank you. Okay. That is the range for the engineer production. we need to figure out the margin of error, which means I need to find exactly in the middle. So how do I find the middle of 144.7 to 145.3? Minus them and then divide by 2, yep. Actually, I don't know. Well, minus would work, I think. No, you don't want to minus them. Minusing, we have to do minusing next. We want to find the average, so we need to add. Sorry, I was thinking the next step. 144.7 plus 145.3 divided by 2. That's how we find the midpoint, right? Just like you did when we had the question, it was like, what's the midpoint between 1 and 2? 1.5. That will give us, if we minus, we would have got our margin of error. Three and 3. What's the answer? Okay, so now we need our confidence interval. 145 plus or minus. What's my margin of error? How do I get to the range? How do I get to 144.7 and 145.3? What? Subtract what? 0.3? So you could go 145.3 minus this. You might even be able to see that's how we got it. But if not, you minus 144.7, you get the margin of error. We'll do B and then we'll call it. What is the relationship between the confidence level and the sample size? Let's go back to your chart. What do you notice? What is the relationship between the confidence level and the sample size? Thank you. Thank you for taking the risk and furthering your understanding. It says, what is the relationship between the confidence level and the sample size? So just look at the two numbers. We have a sample size of 45 and we have a confidence level of 90%. We have a sample size of 65 and we have a confidence level of 95. So as the sample size goes up, what happens? As the sample increases, so does the confidence level. Okay, so the bigger the sample size, the more confidence we have, the lower margin of error we have because we're testing more. Okay, all those things. And you have an assignment, I believe, 3, 4, 6 to 9. Tomorrow's a review period, and your exam is on Thursday. That's chapter 5.1 all the way to 5.6. So you maybe need to do some homework tonight.